Good evening.
Okay.
Good evening, sir.
Okay, let me call the register. Godfrey, are you present? Godfrey?
Present.
Okay, Ian? Ian, are you present?
Yes, I'm present, sir.
Present.
Okay, and Kennedy?
Present.
Okay, so welcome to our today's class. Today we want to talk about separable differential equations, and today we are going to talk about separable differential equations. By the end of this topic, the learner should be able to define a separable differential equation and identify separable differential equation. And then finally, the learner should be able to apply separation of variables to solve differential equations. Yes. Okay. Now, in our next slide, Kennedy, can you please read for us the definition of a separable differential equation?
A separable differential equation is any equation that can be written in the form of y prime is equal to the function of x gy.
Yes.
Or yes, okay.
Yeah, go ahead.
Or y prime is equal to f of x over g of y.
Yes.
So y.
Yeah, that is very true. That is the definition of a differential equation. Now, Godfrey, can you read for us the next statement?
Let me read it. Y
Yes.
prime is equals to
Hello. Hello. You're not getting you. Maybe your network has a problem. Okay, Godfrey. I think your network has a problem. Mwangi, are you present?
Yeah. Plus or minus g of y is not a separable differential equation.
Okay, Mwangi, can you repeat what Godfrey has said?
Definition.
Yeah.
A separable differential equation is any equation that can be written in the form of y prime is equals to f of x, g of y, or is equals to y prime is equals to f of x all over g of y.
Okay. So what can you read for us the last statement? The last statement.
Y prime is equals to f of x.
Yes.
Plus or minus g of y is not a separable differential equation.
Can you tell us why? Who can tell us why that is not a separable differential equation?
It's not a separable differential equation because,
yes,
as you can see, the f of x and g of y are on one side.
Okay. Who else can give us an answer, a trial? Kennedy?
I think from the definition,
yes,
a function is only separable if it is either a multiplication of two functions or a division of the same. So if you add the two or subtract the two, it cannot be separable.
Yeah, that is a better explanation. So, Mwangi?
Okay.
Yeah, Mwangi, so just to sum up this slide, this function, the y prime is equals to f of x times g of y. is a separable equation because from the definition, it has to be a multiple or a quotient, yeah, of two functions.
Okay.
Yeah. If it's not,
Okay.
then that is not a separable differential equation. So from this definition, you can identify a question that is a separable differential equation and that which is not. Yeah. So that which is a separable differential equation, we can use separation of variables. That which is not, we use other means. So it's only these equations A and B that are in this form that can only be, the separation of variables can only be applied to such. Are you together?
Very.
Okay, yeah. Let's proceed now. Doreen, are you present? Doreen.
Yes, I'm present.
Okay, can you read for us the topic for the slide?
Separation of variables.
Okay, that's nice. So, okay, let me see who is here. Clivius, are you present?
Yes, sir.
Can you read for us
Yes, I'm
the
present.
equation that is on the display?
Okay, separation of variables.
Yeah.
Y prime is equal to f of x multiplied by g of y.
Yeah. So
which shows that y prime
is
equal to dy dx, which is equal to x multiplied by y.
Yeah. Now, in this equation, y prime is the same as dy dx. So what we have done here, we have substitute the dy dx in place of y prime. So we are going to have dy dx instead of y prime to give us x is equals to x times y. With that, so after doing that, we are going to have this slide. Ian, can you tell us what has happened here?
Okay. Dx, dy over dx.
Yes.
Is it minus or what?
Is equals to?
Equals to x times y.
Okay, before you proceed, can you read for us the heading?
Grouping like terms.
And in bracket?
Separating variables.
So what happens here in separation of variables? Ian? Hello? Ian, are you together? Are you with me?
Yes.
Yeah, what has happened here? We have divided all through by y and multiplied all through by dx from both sides, yeah? Are you seeing that, Ian?
Yes.
Yeah, we divided all through by y so that we can separate the y variables and then multiplied all through by dx so that we can have x on the same side. So this y and this y will cancel. And then this dx and this dx will cancel. So I'm going to remain with the y variables on this side and x variables on this side. Have you seen that, Ian?
Yes, sir.
Yeah, the whole class, have you seen that?
Yes.
Yeah.
Yes.
Okay. So after doing that, we are going to, let's see what awaits for us. Now, after doing that, we're going to have such an equation like this one. So let me pick someone. Okay. And let me have, who is this Xiaomi? Xiaomi and to something.
It's me, sir.
Oh, okay, Manuel.
Yes.
Okay, Manuel. Manuel, can you tell us what is happening here?
Yeah, we were introducing the integral sign to both sides of the equation.
Yeah, that's very nice. So when we introduce integral sign to both sides of the equation, we are going to have an equation like this. So Emmanuel, let's proceed to the next slide and then tell us what is going to happen. So what has happened here, Emmanuel?
When we integrate 1 over y dy, we
Yes.
get the natural log of y.
Yes.
And when you integrate x dx, you get x squared over 2.
Yes.
Then plus the integral constant c plus c.
Yeah, that's very nice. That's true. Now, after doing that, what do? We introduce an exponential here and also here. So when you introduce the exponential, we're going to have the value of this one as y and the value of this one as now. When you remember back, there is something called the laws of indices. Yeah. Yeah. Now, when the bases are the same, we add the powers. Now, here, the powers have been added to the exponential now. So to separate them, we are going to have exponential x squared over 2, and then times exponential power c. Now, when the bases are the same, we add the powers, and that's what has happened here. So we're going to separate this. We're going to have exponential x squared over 2 times exponential power c. Have you seen that, class?
Yes.
Yeah. Now, after doing all that, now let's see our equation, how it becomes. So I'm going to have an equation like this. Now, this is what I just did earlier. Yeah, so I separated. Now, when the bases are the same, we add the powers. Now, when you separate, we have exponential power c times exponential x this one. Now, exponential natural log of y becomes y, and exponential of c is also a constant, yeah? So exponential c, exponential of a constant is a constant.
Is a constant.
Yeah. So I'm going to replace this with another constant, yeah? Yeah. So I want someone to tell us the answer that we're going to have here, just from the slide. Okay, Doreen, can you read for us the answer? Is Doreen present?
Yes, I'm present.
Yeah, can you read for us the topic and the answer?
Explicit function of y.
Yes.
Y is equals to
Yes, C.
C.
Yeah.
C multiplied by E
Yes.
to power x squared over 2.
Yeah, now that's the answer that we are going to have. That is y is equals to C, which is a constant, times the exponential x squared over 2. Okay. To finalize our class, Emmanuel, can you read for us? Can you tell us what you have learned in our today's class? Just one, and then someone else.
I've learned that we group like terms when we're finding the solution for differential equations.
Yeah. Okay. Kennedy, can you tell us what you have learned?
I think I've learned that a function is only separable when either a multiplicative or a multiplication of two functions, or otherwise quotient of the same. But if it's addition and subtraction, you cannot separate them.
Yeah, that's nice. We use another means, maybe exactness, all those other formulas. But for separation of variables, we use those two conditions, either a multiple or a quotient. Okay, Ian, what else have you learned?
Okay, I've learned about the implicit function of y.
Yes.
And the explicit.
Nice, that's very true. Okay, Godfrey. Godfrey, are you there?
Yes, I'm here.
What have you learned in our today's class?
I have learned that after separating the two variables, you have to
Yes.
integrate both signs.
Yeah, that is very true. Yeah, thank you all. I think we have, hope you have all enjoyed the class.
Yes, we have.
Yeah, so we are going to meet in our tomorrow's class. Make sure when you come tomorrow's class, you carry your calculators and the tables, yeah, so that we can see what to do. Okay, before you break, there is a question here. You can test your knowledge for the quotient one. The one that we did was for the multiple one. Okay. Thank you all and have a nice day.
Thank you.
Okay, goodbye.
Thank you, sir.
Okay.